Why not? A few more people just came in. Anybody have questions for mini homework? Anybody? Homework that everybody is definitely doing. Okay. And just remember, you don't have to wait until the due date to turn homework in. You can turn homework in the minute you get it done. Right? Okay. So we pretty much finished section 1.6 yesterday about probability. The homework is very straightforward in that section. So I'm hoping that won't be too big of an issue. If you just remember the basic idea of how to put together a probability, right? It's the number of things that match what you're looking for divided by the total number of things that could happen. That's all it is, right? Okay. And I kind of gave a preview of where we're headed. So let's do this. Let's try something different here. Sure, why not? Let's do a little homework together. Why not, right? Why not? A little gift for you guys who are here. Maybe I should stop recording. No, I'll keep recording. So, for example, let me see. Maybe I won't do the homework itself, but I'll do stuff like it. What would 10 to the third be? What does that mean?
10 times 10 times 10.
Good, because powers are based on multiplication.
Mm-hmm.
So what would that be?
1,000.
1,000. Right, and it kind of is nice. Look at how beautiful this is. The power on the 10 is a third power. How many zeros were in the answer?
The same number as the power.
Holy shit. So you got to love that. So what could you do 10 to the 17th power? How would you do that really quickly?
Yeah,
You would write a 1.
17 0.
17 zeros. I don't feel like that. 0, 0, 0, 0, 0. Okay. All right. How you guys doing so far? Nothing major. Okay. All right. Now, here's something else that is involved in this homework. What does a negative power mean? So, what does a negative number mean? Like, if I have 5 plus 2, then it increases. If I have 5 minus 2, then the amount of stuff I have decreases, right? That we know that. That's very simple. But a power is based on multiplication. I really want to see everybody with me. So we know a negative means losing something in a very basic sense, right? But okay, I got a chat coming. Hold on. Yeah, exactly. Okay. So when I'm combining things, a negative is the opposite of addition. So instead of gaining stuff, I'm going to lose stuff additively. Exponents are based on multiplication. So if I have a negative power, that means I'm going to divide some stuff away. Now everybody stay with me. Here we go, right? So for example, how would I figure out? Can you guys tell me real quick? Let's talk about exponents for a minute. What is x squared times x cubed? Do you guys know what that is?
Yes, we add the exponent. That means
All right,
x.
let me make sure everybody else is with us.
Okay.
Let me ask you this real question. You guys ready? All right, let me ask you a question. Look at this right here. Look at this right here. I'm not going to ask you a question. I'm going to make a statement. There is no 2 anywhere here. There's no 2 in this anywhere. I don't see any 2s. I don't see any 3s anywhere in here. Does anyone believe I am insane? You could go, well, I believe you're insane, but not for that, Jeff. But all right, understandable. So because that is not the number 2. What does this mean up here?
It means x times x.
Yeah, it means you have 2 x's. I don't have any 2s. All right, so if I have 2 x's in a row, right? If I have 2 x's in a row, and then right next to it, I have another 3 x's in a row, well, then how many x's in a row do I have?
5 x's.
Freaking 5. Yeah, okay. I love it. Is everybody with me so far? I can't remember. I don't think we've talked directly about how exponents interact like this. I might be wrong. I don't know. I don't think we have. All right. Let me keep going with this exponent stuff. I'm going to clear all this away. In fact, I'm thinking, no, screw it. I'm going to stay right here. I'm going to clear all this away. I'm going to build up to this 10 stuff again. All right, stay with me. Let me get blue here. All right. Now watch this. So what would this be? Oh, why did I pick 7? I have no idea.
Yeah. X to the power 7 minus x to the power 4.
No, careful. I know what you mean, but that's not what you're saying. Division cannot become subtraction.
Ain't that multiplication?
No, because I'm dividing. So
Oh, okay.
I'm going to do something that I never want. Can you guys? All right, you don't need to say something to me. Stay muted, okay? I'm going to do something I never want you to do it, but I want you to see why this works the way it does. What is on top? There are 7 x's multiplying, right? Why did I pick 7? Why did I pick 7? Is that 7? 2, 3, 4, 5, 6. Okay. And on the bottom, there's 4 x's. Ooh, Jeff, this is groundbreaking stuff. How many x's cancel? Because division is the opposite of multiplication, of course.
4.
4 x's cancel. I love it.
So that would be 3x.
Be careful. How do you say it correctly?
3x. X.
No.
X
To the power 3.
3.
Kick ass. X cubed, x to the 3rd power.
Yeah.
I love it. I love it. So what's the shortcut? Never do this weird shit, right? What do I do with these powers?
Subtract the power.
Subtract the powers. I like it. So for example, again, if I had x to the 18th divided by x to the 3rd, that would be x to the what?
15.
15. I love it. What about this? All right, let me see. Let me number these a little bit. Let's see. What about this? What is x to the 4th divided by x to the 4th? Doing what we've been doing.
1.
Yeah, but what would it be? X to the what?
Yes.
No. How did we get 15 here? What did we do? How did we get 15? How did we get? Yeah, we subtracted
18 minus 3.
minus 3. How did we get 3 up here? 7 minus 4. So this will be the what power? 4 minus 4. I hear some interesting noises back there. Oh, okay. Guys, are you with me? Everybody got very quiet.
Okay, a question. Anything to the power 0, that means 0 or 1?
No. Here we go. That's what we're about to prove. I just want everybody to be with me on what we just did. Everybody was fantastic there for a while. And then, well, actually, I don't know. Most of you guys are just boxes with names. So as always, if you can, turn your camera on. You don't have to. but I would love to see people. It would be amazing. Is everybody cool with it? Anybody not cool with this result? Let me take that line away so you guys that don't think it's something weird there.
Oh no.
No?
So like I hear you and everything like that, right? But I don't understand why you would put a 0 there and just not X.
Okay, now watch. I love it. Beautiful, beautiful. What's the power understood to be on the X?
I think
First
one.
Because if I just write X, how many X's did I just write? 1. So that's why I don't even put the power. If it's a first power, why would I? So if you see X, there's actually a 1 here, there's a 1 here, and there's a 1 there, right? Can't I put a 1 underneath anything? Don't we do that when we have fractions and I want to make a whole number look like a fraction, right? And there's an understood 1 out front, and there's an understood 1 up here. There's a lot of understood 1s. So now watch. So let me ask you this. What is x to the 5th divided by x to the 4th? What would that be?
X to the power 1.
Yeah, x, because it would be x to the first power. Right? Everybody with me? Because 5 minus 4 is 1. So what's 4 minus 4? 0. Now, stay with me. I know. 0 power, what the hell does that mean? Wafa basically told it to us. What is something divided by itself?
1.
1. So anything to the 0 power is 1. Let me show you a different way to think about that. I really need you guys with me. Some of you guys, this is old news. That's fantastic. But I need somebody to give me some kind of reaction sometimes. Now watch this. I really want you to get this. So if I write x cubed, there's a 1 out front, isn't there?
Yes.
You guys with me? Okay. If I write, now watch. If I take an x away, like I divide an x away, what do I have now? Don't I have 1x squared? Are you with me? So I divide an x away. Is that cool? Are you guys with me?
Yes.
If I divide an x away again, what do I have now? I have 1
You just have one x.
x. If I divide an x away again, how many x's will I have?
We
You
don't have.
You still have one x, right?
No,
We
no.
don't have any
Zero.
X.
Yeah, 0 x's.
Don't I keep losing an x? When I divide by an x, I lose an x. When I divide by an x, I lose an x. So if I divide by another x, how many x's do I have? 0 x's. 0 x's. So what do I have left? Just
Only
the
one.
understood 1. That's another way to realize that x to the 0 means no x's. So then what do you have? You just have that 1 that's always there. I really want this to make sense. Okay, maybe. All right. So that's just a fact. Anything to the 0 power is 1. I love you guys. I love you guys. I really want that to make sense. It is not the same thing as x times 0. What is x times 0?
0.
0. I love it. And let me see. I've never tried this before. Let me try this. I'm gonna clear all this away. You guys ready? I'm gonna clear all this away. I don't know. I don't feel like going on my whiteboard for some reason, so I'm just gonna do it here. We'll do it live. All right. I'm gonna clear all that away. Now watch, real quick. I've never tried this before. You're my guinea pigs. It just came to mind. If I have a 1 plus 3. Screw it. If I just write a number, this could be a dumb thing. Isn't there can I put a plus 0 on it if I want to? Does that change it? Yeah. So, not screw it. I'm not going to do it. I got to work on that. I think there's something there about teaching, but I just came up with it. So I got to work on that. All right. I'm sorry about that. I'll have to come back to that. I think there's something there, but I don't want to try to put it together on the fly. All right. So x, anything to the 0 power is 1. And let me prove it to you another way. Now here's a way that I'm not making up. This is a what's the only thing that I can multiply something by and it stays the same?
1.
Is that cool? If I multiply it by anything else, it won't stay the same. Does everyone agree with me? If anyone doesn't agree with me, I want you to show me what else I multiply by and it stays the same. Right? Please, please show it to me. Okay. I think you guys are with me on this. So watch this. If I multiply something, I'm going to put something right here. If I multiply something by x cubed and it stays x cubed, I really want you guys with me. Whatever I put here, if this is true, stay with me. I'm going to put something in that blank space. If I multiply it by x cubed and it stays x cubed, what must this thing be?
1.
1. I love it. What do I get when I put an x to the 0 here?
It becomes 1.
No, stop. Stay with me. Real quick. Recall, what is x cubed times x to the 7th, for example? That would be x to the what? What do I do with these?
Add.
Yeah, so that's x to the 10th. Are you with me? Everybody with me? So what is x to the 0 times x cubed?
0 plus 3. That's me. 3.
Which is
3.
3. So it stays the same. So what must this be then? Since I multiply by it and it stays the same, what must this be? It must be freaking 1. So I've shown you several ways to see why raising to the 0 power makes something 1. Okay, I like it. Maybe, hopefully. Okay. That's very interesting. If you multiply by something and it keeps that thing the same, whatever you multiply by must be some version of 1. All right, that's a very neat thing. Now, what about, let me push it here. You guys ready? I don't know. What about negative powers? Come back to this. Okay. So we sort of started talking about this and then it took a little sideways. Negative power. So watch this. What would x squared divided by x cubed be? What do I do with the powers in this case?
Subtract the power. It's minus
Yeah,
1.
so what's 2 minus 3?
Negative 1.
No. 3 minus 1.
No. Why are you changing things? Things cannot change. What is x to the 8th divided by x squared? That's x to the 6th. 8
Yes,
minus 2.
Yes.
I like it. Stay with me now. What's another way to write x squared? Isn't that x times x? What about x cubed? Isn't that x times x times x? Stay with me. How many x's cancel
2.
here? 2. 1, 2. How many x's are left?
Negative 1.
No, careful. No. How many x's are left?
1.
1.
1. Where?
On the bottom.
There you go. So what does a negative power mean? It means flip. Like we said earlier, negative should mean I'm losing something. How do I lose something multiplicatively? I divide it. So a negative power means division. I'm losing an x. That's what, so if I divide something by x, don't I lose an x? What is x to the 8th divided by x?
X to 7.
Right, because I had 8 x's and I divide 1 away. So didn't I lose an x? So what is x to the 8th times x to the -1? Isn't that also x to the 7th? So a negative power means flip. That's a better way to think about it. Something to a negative power flips. So look at this problem right here. We might as well do one of your problems. How do I do that problem here? What do I have to do? What's the negative power mean?
Divide.
Yeah, flip it. And then I still have to cube it. So a negative third power means two things because it's got two parts. The negative part means flip it. And the third power means cube it. So what would that become? 1 over 1,000. I really want you to get this. So watch. Let's do a, shit, hold on. Let me clear all this. I'm going to clear all this away. Here we go. Okay. Oops, somebody chatted at me. Watch. We'll do a quick fire thing. Oh shit, I got to turn on my, hold on. There we go. What's 3 squared? Three squared.
3 times 3, 9.
Yeah.
9.
Yes. So 3 to the -2 is 1 over 9. What's 4 squared?
$16.
So then 4 to the -2 is 1 over 16.
16, yeah.
You understand, all a negative power says is take whatever it would normally be, flip it. Oh, I love it. Somebody's asking, where did the 1 come from on the top? I love it. There's a couple ways to think of that. The way that I personally prefer is, what is in front of this? What is in front of everything? An understood 1. So when those 2 3s go down, what's left behind is the understood 1. All right. You guys okay out there? I need you guys with me. Okay, let me see. Here we go. Here's another chat. Kinda. Okay. So let me show you something. I don't know if this is gonna help at all. Let me clear all this away. So what would I want you to see something here. Let me see if I can push my luck here. All right. What's the only part of this that doesn't like where it is, that wants to go somewhere else? This is a very interesting way to say this.
Is it the B
The B
Yeah, where would those 3 B's rather be?
on the bottom?
on the bottom.
Yeah. So the A squared would still be there. And then the B cubed would go on the bottom, and the C4 is still there. Bam. So what I'm trying to say is, I can see this A squared, so of course it's here, right? But if I just had B to the -3, and then somebody says, why did you put a 1 there? Because there's an understood 1 here that doesn't show up until the thing it's in front of goes away. Then the 1 shows up, right? Just like those 2 A's were there. Where'd they come from? Well, I can see those. Where'd that 1 come from? Oh shit, it's that hidden 1 that's always kind of there. No, maybe, no.
I'm seeing
Screw
it.
you, Jeff. Yeah,
Okay,
we're building
question.
up to that.
If we put instead B and C the numbers, that's mean we'll put times in the middle, right?
Where? Oh, here?
Yes. If we
This one
put
right here?
numbers, real number.
Yeah, of course this means times because they're sitting next to each other.
Okay.
Yeah. So even without real numbers, they still mean times. Yeah. Cool. I like it. I like it. All right. Now, here we go. Oh, let me see. I'm going to clear all this away. We are ready now for scientific notation. Here we go. I'm going to clear that away. Let me find some. Here we go. Oh, here's a lot of white space. Dude, all right. So watch this. Here we go. 4,000. Couldn't I write this as 4 times 1,000? Everybody with me? I mean, you're like, if you want to, math boy, go ahead.
Yes.
Okay, I like it. And why is this an interesting choice? Because I've got a single digit times a certain number of tens. In fact, how can I rewrite 1,000 10 to the what power?
3.
Yeah. That is scientific notation. Oh my gosh, I am writing so well today. Sorry. That is scientific notation. So scientific notation is officially a single digit with well, let's just do this for right now, times 10 to a number. So it's sort of like, I like to think of scientific notation as a tens vampire. It sucks all the tens out of something. That's a very strange way to think about it, and I don't care. It might be because I've been catching up on my What We Do in the Shadows thing. But no, I often talk about this as a vampire that sucks the tens out of something. So I'm left with, the thing I'm left with has no tens in it. It's a single digit. All right, this is very important. What about, can somebody remind me, how would you write this as a fraction? What place is this in? This 4. What place is that in?
1,000.
4 times 10
1,000.
Stop.
minus
No,
3.
no. Stop. As a fraction, how would I write it as a fraction?
4
What
over
place
1,000.
is tenths, hundredths, and I think somebody did say this, thousandths. You guys all with me? Are you with me?
Okay.
Did we talk about a quick side note? Do you guys know why this is the tenths place? And this is the hundredths place, this next one? And so forth, right? Once you're past the decimal, you got to have a lisp. The tenths place. Do you guys know why? Anybody? Do you guys want to know why? Or you're like, no, Jeff, I just want today to end.
I want to know why.
Okay. Now watch. I love it. So thank you you're like, God, what will shut this guy up? Let me just tell him I want to know. Okay. Watch this. I know you didn't mean that, Caitlin. I'm not putting words in your mouth. Hopefully you didn't mean that.
Oh, it's
Um,
okay.
What is the 9? What's the place the 9 is in? Let's do some nice, crazy little things. What place is the 9 in? What place is the 9 in?
1,000.
Thousands, right? This is your time to shine, everybody. What about the 8?
100.
Hundreds. What did I do? This place, how did I get to the next place? Didn't I divide by 10? What's the next place?
Tens.
Tens.
10. Again, I divided by 10. From 100, I divided by 10 to get the next place. What about the 2? It's in the ones place, right? Again, I divided by 10. So it shouldn't be surprising what place is the 5 in. I take the last place and I divide by 10. So it's in the tenths place. So the 6 will be in the 100ths place. That's it. That's it. So how do I know how to write a decimal as a fraction? I just go tenths, hundredths, thousands. Oh, it's 4 thousandths. The same way that this is 4 thousands, right? Isn't that another way to say this? 4 thousands. This is 4 thousandths with a lisp. And I'm really sorry. I'm not making fun if you have a lisp.
Professor, I have a quick question.
Yes. Yes.
So for the one where you have 0.004 equals 4
Yes.
over 1,000, only
Yes.
reason why it's kind of like a clarification thing. The only reason why you have 1,000 underneath the 4 is because it's behind the 4.
What's
Like
behind
the 3 zeros. Does that make it like? Never mind. I actually scratch that. Scratch that.
Oh, there's a shortcut here. There's a shortcut, but the reason why this is 4 thousandths is because this is the tenths, hundredths, thousandths place. That's it. But the
Okay.
shortcut is, I think you're almost on the cusp of a shortcut. How many decimal places are here? 1, 2, 3. So how many zeros? 1, 2, 3.
Okay. I'm seeing.
Yeah. So I thought you were right on the edge of that. All right. Which is beautiful. Now, I'm not done with this poor little fraction. I'm not done with this poor little fraction. I'm going to mess with it some more. Come here. That's all math is math people are just number bullies. We're like, come here, number. Let me do some weird shit to you. All right, here's where things get interesting. Remember how I can rewrite 1,000 as 10 cubed? Are you guys with me? So anywhere where I see 1,000, I can make it 10 cubed if I want to, because they mean the same thing. Is that cool?
So that'll be 4,000.
No, because it's not 4 times 3 tens. It's 4 divided by 3 tens.
Okay.
I can't make 0.0004 or 004 become 4,000. I can't do that.
Okay.
I like it. But what if I brought this back up top to make it look more like this? If I bring this up, what has to happen to the power?
Becomes a negative.
Negative. Oh,
The negative, to remind me that it actually wants to be on the bottom. Isn't that cool? So if the number starts off big, the power will be positive. If the number starts off small, the power will be negative. Isn't that nice? Now, I know some of you guys know scientific notation. I am getting to the direct part now. We're done with the concept. Let's do a couple problems directly where we talk about moving the decimal place. I think some of you guys know this. Watch this. How many times in the number 4,000, where is the decimal in the number 4,000? Where's the decimal up here in the number 4,000?
After the last zero.
After the last zero. How many times would I have to move the decimal to get it to be behind a single number? In this case, the 4.
3.
3 times. That's why the power is 3. What about in 0.004? Let me get rid of all this weird crap. Okay. How many times would I have to move the decimal in this number to get it behind the 4?
3.
3. So it's still 3, but it's negative because it was a small number. So look up here. I really want this to make sense. If I take 4 and I multiply it by 10 3 times, it's going to get bigger, isn't it?
Yeah.
So if I just multiply 4 by 10 3 times, I will get 4,000. These are actually the same number. So down here, what does a negative power mean? It actually means divide. If I divide 4 by 10 3 times, it'll get smaller, smaller, smaller. Again, it's the same number. It's just a better way to write it. Now, mute everybody. You guys you got to get better on that mute stuff. So if you're not saying anything, mute yourself. All right. I'm going to clear this away. Here we go. I'm going to clear all this away.
Exponents create a fraction.
Say again, sorry.
Negative exponents create a fraction.
We know that, don't we? Remember, what is b to the negative 3? Isn't it 1 over b third? Yes, so we know that. We know that's what it does. Okay, I'm going to clear all this away. Oh, shit. What did I just do? Okay, here it is. All right, now watch. So if I want to change into scientific crappity doodah. All right, I can't write, I can't spell. What a great job for me. All right. So here we go. All right, look at that yummy number. Look at that. That is a yummy number. Let me see. You guys know what number this is? Let's find out. This means thousands, right? Let's count it out. Thousands. What comes next?
Millions.
Millions.
All done. Go sit down. Eat your food. It's fine.
Billions.
It's okay.
Billions.
No, it's okay.
Trillion.
Go eat your food.
Trillions. Now, does anyone know what comes after trillions?
Not a clue.
Mama,
Quadrillion?
Quadrillion?
Oh, I like the quadrillion. Maybe I should make that into a bonus thing. All right. Anyway, all right. So it's a very, very large number. Now, let me see. Let me erase this. If you guys can look up. In fact, what did I put up? Let me show you something real quick. Well, I'll show you in a minute. Let's change this into scientific notation, and then I'll show you something I put up for us on Canvas. Where's the decimal place right now in this crazy ass number? Where's the decimal place?
At the very end of it?
Very end. How many times do I have to move it until there is one digit in front of it? So where do I want it to end up? I just want
9.
one digit. Say again, sorry?
In front of the 9?
No, because then there would be 3 digits in front of it.
In front of the 1, all the way to the left.
Behind the first one, yes. So I want it to end up here. So then there's only one digit in front of it. So how many times do I have to move? 3, 6, 9, 12, 15, 16. So this becomes 1.119 times 10 to the positive 16.
That makes sense. I see it.
That's based on everything we've done before right now. So move the decimal, and basically this whole process is the vampire part. I'm sucking all the 10s out and putting it right here. There's all the 10s. Put the decimal after the first digit. And I know this is going to be positive because it's a big ass number. What about this number? Kind of sucks counting these zeros, I know, but where do I want to move the decimal? It's obviously right there. I want it to end up where?
After the 4?
No, because then there would be 2 digits in front of it.
Oh.
So after the
The
Two.
2.
2. So how many times do I have to move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what's wrong with this?
Negative.
Why is that not right? Sorry?
Negative because small number.
Negative, so it becomes small. I like it. So I'm actually dividing by 10 times. How you guys doing out there? You gotta kind of like that. I mean, relatively, that's not that bad. It's just counting how many times you move something. If it starts small, it's a negative power. If it starts big, it's a positive power. That's really kind of nice. All right, let's see. What time is it? Okay, all right, cool. Let's do some of the other way. What was I about to show you? Oh yeah, let me show you this. All right, I'm gonna clear this away. You guys ready? Here it goes. I'm gonna do more than that. I'm gonna go like this. Haha. Let me show you what I put up in Canvas, if I can find Canvas again. There it is. You become a student. If I go down here, this is brand new. SI prefixes. So SI relates to our system of units, system international. So this is not our system of units, actually, it's the metric system, but oh yeah, this doesn't go up far enough. So here's your quadrillion, right? So that's exactly right. It went down to quadrillionth this way. It didn't go up far enough to see that that is quadrillion. I like it. But this does show you the standard words for the relative size of things. Are you guys with me? Up to a trillion. You can put one more. So everybody said quadrillion. Beautiful. You also have these. Have you ever heard of these? I know you've heard of gigahertz, gigabytes. Have you ever heard of gigabytes? Has anyone ever watched Back to the Future where they mispronounce this? Giga, he says gigawatts. Yeah, because they didn't know how to pronounce it when they put it together. I'm like, oh, come on, man. Megatons. Anybody ever heard of megatons? And I know you guys know kilo, kilometers. If you watch the crime shows, or if you are involved in crime, you might have talked about kilos of cocaine or something, right? Okay. If you are involved in crime, please keep that to yourself and maybe stop. I don't know. It's up to you. I'm not going to tell you to live your life. All right. So that's up there. This is kind of nice as a quick little reference. So last thing for today. Let me see. Let's do some the other way. What do I mean by that? I don't know what I mean. If I gave you this number, can you translate it back from scientific notation? So if I said 7.3 times 10 to the negative 4, could you write that as a regular number? Do I want to make the number become smaller or bigger?
Smaller.
Mhm.
Good, because it's a negative power. So, and here's the cool thing about negative powers in scientific notation. I've got to go once to get around that number, and then 3 more times. So there's going to be 3 zeros in front of there. So it'll be 1, 2, 3, 7, 3. See, that's 1, 2, 3, 4. Do you see that? So there'll always be one less zero than this says, because it's going to take one step to get around that dumb number. That's kind of cool. And of course, if I said 5.12 times 10 to the 7th, what's the quick way to do that? I got to do 7 total steps. So I have to take 2 steps just to get here. So how many zeros will there be?
6.
No.
5.
How many total? Yeah, I've got to do 7 total steps. I've already done 2 of them. So then 5 more steps. Cool. And then you can throw in some commas to make it easier to read. Okay. All right. What time? I think we can. Wow, this is early. I've done everything I wanted to do today. That's crazy. We're done, guys. Let's take an early day. What do you guys say? Is anybody upset at me? Do you think you're not getting your money's worth? I'm sorry. I've actually had somebody get angry at me because I let us out early a couple times, and somebody's like, "Yeah, that was my reaction, basically." All right, guys. Let me know if you have any questions. Otherwise, you are free to go.
See you next
Thank
week.
Guys, don't forget about Mars today.
Oh, what time is that? 1?
Yeah, I think it's 1:30, but the coverage starts at 11:30.
What happened at
And
one
if you
point?
want to watch it, it'll be on this website here. That website will have coverage. I think it starts at 11:30, but I do think it lands at 1 or 1:30. All right. I'm gonna head out. I'll see you guys.
Monday.
Thank you so much, Professor. Have a great weekend.
You too, man. Bye,
Take care.
everybody. Take care.